Hello everyone. Last time we did the modeling of this beam and we reached to the job. Uh, Today we have run the job and we will see the results. And just to remember, this was the job We have done. We can see monitor just to see the analysis how it was gone. Now we can see that it's not completed. The status here is showing that it's aborted. It means something happened. And when we open this, we can see, you can read in this errors and this under the errors tag, too many increments need to complete the step. The problem is, if you remember that we put the full time for the application of the displacement as 10 seconds. We have reached to 9.94244. So we did not reach 10. And the number of the increment we have reached here is 10,000. So 10,000 increment, we reached to 9.94244. Why we couldn't finish this the full displacement? Because we have, if you remember in the step properties and the step options, we have specified the maximum number of increments as 10,000. So when he reached 10,000, whatever is the total time or the step time he reached, he will stop. And just to remind you, we can go back to step here. This is our step, edit, incrementations. See, the maximum number of incrementation is 10,000. So in order to avoid such mistake, we just have to like increase like one more zero. No, it's 100,000 or 1 lakh. So now he will continue the job till reaching 100,000. Here also, just to compare the maximum, minimum, and initial, if you can see, this is the time increment. This is the time increment for each step. We can see now the incrementation is 0.001, which is the maximum. If you go up a little bit, this is the initial, the first step, step number 1, initial. The initial is this. We specify the initial as 1 into e to the power of minus 5. So it will be 1e to the power of minus 5 or 0.401. So this is the initial. Now he will see like, okay, the initial is good enough, so he will increase it. Now we can see he's increasing the steps since no problem he's facing, and especially we are in the linear phase. Now still he's increasing the time increment until he reaches the maximum time increment as I specified here. The maximum is 0.001, so here it's 0.001. He cannot make it bigger than this. So he will continue using this maximum time increment until he faces any kind of difficulty. Then he will again go to minimize the time increment for the step. We can see like it's almost only the maximum increment uh, because first of all in the beginning it will be linear only, so no difficulties. The difficulty will start when we go to the non-linear phase, and especially we are using a very big mesh, so also even if it goes to the non-linear phase, maybe the difficulties will not be needed to go to see here it looks like he has some difficulty, so he goes to minimizing the increment. He minimizes it till he also again say like find that okay, no need for small increments. He goes back to maximum increments again. So again
Here also you can see that he's minimizing and maximizing, again minimizing, maximizing, until he finished, he reached to this, the maximum increments. For our situation, since 10,000 he stopped, it reached 9.9, so no need to rerun the job since it's 9.9, almost the full step. So no need to run the job if it's not didn't reach this time increment, or like almost finished. So we have to go back, change the maximum number of increments, and then rerun the job again. Anyway, now let's go to see the results we got. Save changes. Anyway, I will not save it for now, but I will not save it. Job. Now again, results. Now here, I'll be showing my results. In the results, we have to focus on this. Here it's the results, and it depends on what you have chose before in the field output. If you remember, here in the step also, no, sorry, not here. This is the field output, and this is the history output manager. It depends on what we have choose here. Then we will get our results here. So this is the thing that we have chosen, and also we are using concrete damage plasticity model. So the output of this will be occurring here. Let's start with C, damage C. Damage C means the compression damage of the concrete. We can see that the compression damage is only occurring on these two nodes. Only here. Since it's a flexure, like it's 3-point bending, so with reinforcement to be flexure, so the damage will be mainly tension damage actually. See, now we can see the damage, the tension damage of the concrete. And let's start from 0 time step to see how the cracks initiated and propagated. We can see, we can see that the cracks has initiated in the middle, in the flexure span, which is a perfect flexure cracks. Then it will increase again and again. Now we can see other cracks are initiated also because of reinforcement. It will distribute the stresses to other regions, and cracks will initiate it in other regions of the beam, all along the beam. We can see. Anyway, let's just make it faster. We can see the cracks, how the cracks initiated and propagated on this beam. Since it's a flexure, you can see it started from the middle, then it start distributing. Anyway, our mesh is also, I have to mention again that mesh is big, so you have to be careful, and this is just for a like representation and visualization of the results. Let's move on to let's see all these kind of things, like you can know about it in Abacus documentation. It will know like what is damage C, what is damage D, what is E, what is DEEQ. I think it's plastic equivalent something, and the U is like displacement. S, it's the stresses, the mices. Let's see, now if I want to see the stresses in the reinforcement, so I have to see the reinforcement. So I go here, I go to part instances, okay, beam, I'll remove the beam. Now I can see the reinforcement. Now I can see also like, well, because it's a flexure, how like in the middle it's tension and it's the maximum stresses, it's in the longitudinal reinforcement, bottom reinforcement, longitudinal in the middle of the beam. And here we can see like the mices, like what is the amount of stresses in this step. See, we are in step in 2.648. The increment number is 2684. and the stresses is that in the red here is 400. It's 4.793 into 10 to the power 2, so it's like 479. Uh, we can increase to reach the maximum, or the last step we reached. It reached the maximum. It reached to 543.5 MPa, megapascal. So that means the reinforcement has yielded, right? Because we remember in the properties, the reinforcement we have done, we put is the yielding will start as 469. So, and we have reached 500 something. So we are like almost in this region between this and this. So the reinforcement start to yield. It's 543. That means the reinforcement yielded. And it yielded here in this region. Okay. Just going back to damage T. See, when I go back to damage T, he's telling me the selected primary variable is not available in the current frame or for any elements in the current display group, because since I was viewing the reinforcement and the reinforcement, they don't have damage T. That's why this error or this message occurred. So I have to go back and bring the beam. Please put the beam added. Now it will show. Okay, I just want to show you that here the damage T, see in the red it's 9.9. That means it's fully damaged. Like if you go back a little bit, see here now this damage started to form here, but it's not fully damaged. We can see the damage T is not fully until it reached 9.9. See, it's increasing. It's increasing till now. Now it's fully damaged. Now the full damage started here. Now any red will join this. Now see, only the red, it means it's 9.8 fully damaged elements here, here and here. And these are like other things that you can discover by yourself, and you can see like each one, what does it mean. Uh, PEQ, it reaches 3 to the 10 power minus 2. You have to like to check. It's the plastic equivalent something. You can check on the Abacus documentation for each of these results here, each one of these things. What other things that I can view? I also want to mention that like these kind of things we can change for printing purposes. We can change like the background color from like and we can change also the size of this, the line of this. I remember like for example here I can not in this I think in this for example. Not in this also. Okay, let's see. I think it's maybe here options. Here in the graphics, you can change the background. Like for example, here it's a gradient, top, bottom. Suppose I want to put it solid and the background is white, for example. I say okay. I think we choose that as solid. We should choose the white one. Yes. Okay. Okay. Now it's white. So especially when we want to do some printing or like some taking pictures. Hmm. I just forgot exactly how to change this, but there's an option to change these kind of things. Let's see. Okay, okay, I'll check it later. I check later how to change these kind of things. I'll just graphic options. I'll go back to the defaults. I remember it like was like from here. Maybe this. Ah, yes. Here, the contour intervals, like for example, I have too many controls. If I want to increase or decrease the number of controls, for example, just want to show 4 colors, not all these kind of things. Now I can just say, okay, now only 4 colors will be appear. If I go for Tamishti, for example, now if I go into, I can see the damage. Now only 4 colors will appear, only for all these things. I also can uh, for example, if I do this, now it will be like lines, not banded. No, I want it banded. You can check all the things what will happen. Uh, Limits, maximum 0.9, like these kind of things you can check by yourself. Even like I can also change the text and all these kind of things can be changed. What else can I do? I remember that I have done history output. I can do code for it. I can create from here. ODB history output. I will continue. Now, if you remember, we have defined one reference point, and we asked that we want the reaction and the displacement, and these are both of them. I will start with the reaction. I say plot. Show me the reaction. This is the reaction. In the midpoint, you can see like it's upside down. I have to change it. Anyway, I just save it. Here, just like he's telling me how you want to save it, like as is, as it is, no change. Just name it. I will name it like R, just to distinguish that this is the reaction. Okay. Now go displacement. This is the U displacement. Plot also. This is the displacement. Also, it's like on the negative way. Anyway, I will also save as it is. I will call it like U displacement. Okay. Dismiss. Now I go back again to here. I will operate on XY data. Continue. Now I have these because I saved them. They will occur here. Whatever you will save, it will occur here. Okay, this is kind of like the process that you can apply. Like anything you want to apply. I want to combine. Combine. Now it will come here. Okay, I want to combine on the X. I want to see the displacement. So double click on it. On the Y, I want to see the reaction. Double click on it. But since it was in the negative, what I will do, I will -1 and just like I will multiply it with -1 to change its sign. Now I will plot the expression and see the results here. Now this is the force displacement curve uh, of my experiment. We can see it started in the linear phase, and the linear phase started until it reached and initiated like it looks like here kind of started on a linear phase, it's kind of not linear. Now the first crack, any crack will initiate on the beam, it will come and reflected here in the graph. So any that comes down, that means a crack. Then again, stress is being distributed again by the reinforcement. Cracks again, until we reached like kind of yielding. And we saw that we reached the yielding of the reinforcement, right? It was 500 something. So the reinforcement was yielded. So we can see now it's yielding until it reached the maximum displacement 20. It's not like we reached to the second. If you remember that we didn't reach to the 10 seconds. If we reach the 10 seconds, then we will reach the 20 mm displacement. So it was 9.9, so almost the 20 mm displacement. So this is our force displacement curve, and we have seen that here it's into 10 to the power of 3. So like it's 40,000, not 40, 40,000, and the unit is in Newton since we are using the same. Like you have to the units. We started using in Newton and mm, so everything will be in Newton and mm. So 40,000 Newton, or like 40 kilonewton if you want. And if I want to take this curve, I take it and do some operation on it. For example, on Excel sheet, I go to Tools, XY Data. I can XY Data. Yeah, from plugins, Tools, Excel. So he's telling, okay, what do you wanna here? Like just like transfer direction from Abacus to C, or from Excel to, or you can also go from like the opposite side. No, now I want from Abacus to Excel. Which one I want? This is, I didn't save it yet, so it's temp4, or from current if you want, because this is the current also. I say okay. Now he will process it and take it as it is to the Excel sheet. It will take some time. Now you can see it opens in Excel. This is my, so I can do changes, I can do whatever I want. Here in my Excel sheet, I can do changes. Anyway, now I will not do anything on it, just like this for representation. Close it, don't save it. And also we have another way to do this. For example, I go Tools, I go XY Data, I go Edit, now Temp. Now I can also get the same thing from here, but as XY Data. So I can like do copy paste of it from here, copy paste, Control C, then open Excel sheet and copy paste and draw it. It's also possible. And here he's telling me like the X is displacement and the Y is the force. Okay. So on this, I think we've like talked in general about the results and how to see things. I hope that I have give a general view, not detailed absolutely, just for everything, how the results can be done, and how the model is for a concrete or RCB. I remember that I want to say something that, for example, I want to see a result of a node that is not from history output. Like we know that it's in the middle, so we make it a reference point and we make it, and we did it like a history output. For example, any point in the model, I want to get the results of it. I go to the ODB file output, ODB field output, which is the second one we did in the step, if you remember. I say continue. Now, for example, I want specific node. I will tell him I want a unique nodal. Here, any like integration point, centroid, any one unique. No, for unique, I will not go for a unique node. It means not in the like the node will be like here on this element, on this element. A unique node. Now here the option has changed. Okay, what do you want to know? For example, I want to know um, the stresses, for example, mices, for example, for instance, um, or reaction, for example, magnitude, anything like you may choose. Then, okay, which node you want, element nodes, which one you want to know. I will say edit selection. I want to know for example, this node. I will choose it. Now he will highlight it, like I can highlight it, choose it. Now this is the node. I'll tell him plot. It will also take some time. You can see like here also it's showing the date and all kind of information. All these kind of things you can change. It's taking some time. It depends absolutely like on the model, the data he is trying to generate, and also on the laptop characterization or qualification of the laptop. The laptop I'm using is like kind of good. It's Core i7. So I got this. Stresses here, the stresses, I think. He's telling me the force is 0. Nothing is there. Since RF magnet, yeah, like that. Because there's nothing there in that point. How reaction will come. And here the mices, the stresses is like showing like this. Anyway, just like this is also a presentation how to generate any kind of information about any node in the model. You can use the ODB field output and you choose whatever you want and it will come. For example, spatial U2, element, highlight, edit selection. I will take the same node, for example, plot. I hope it will not take that much of time. It is taking some time actually. Here I was checking the abacus documentation as I said. You can see like this is the abacus, the output. You can see each one, what does it mean? Damage C, compressive damage variable DC. Damage T, PEEQ, compressive equivalent plastic strain. PEEQT, tensile equivalent plastic strain. Like all these kind of things you can know about it here. Now he's giving the displacement for this node specifically. This is displacement and this is through the time. So yeah, that's it. I think we come up with like a general view. I hope you got a good idea of this and have a good day.